This question belongs to the subject engineering mathematics and was asked in GATE 1991. So the question states, show that the product of least common multiple and the greatest common divisor of two positive integers a and b is a into b. Let us solve first part A. So what is least common multiple? It is LCM. So the least common multiple, let us suppose if we are finding LCM of 10 and 15. So the multiples of 10 can be 10 into 1 is 10, 10 into 2 is 20, 10 into 3 is 30, 10 into 4 is 40 and so on. 15 multiples are 15 into 1 is 15, 15 into 2 is 30, 15 into 3 is 45. So here we can see 10 is not present over here, 20 is not present, but 30 is the least common multiple. Okay. Now what is greatest common divisor? The divisors of 10 and 15. So the divisors of 10 are 1 is a divisor, 2, let us start from 2, 2 is a divisor, 5 is a divisor and 10 is a divisor. 1 is also a divisor. So we have 1, 2, 5 and 10. And for 15 they are 1 is a divisor, 3 is a divisor, 5 is a divisor, 15 is a divisor. So greatest common divisor, let us start from the back. 10 is not present over here but 5 is present in both. So 5 is the GCD and 30 is the LCM. Now let us solve this question. So the question is saying if we are having two numbers, then we need to prove that LCM of A and B when multiplied by GCD of A and B, then it is equals to A into B. As in the previous example, for 10 and 15, the LCM was 30 and GCD was 5. And what is 15 into 10 is 150. And 30 into 5 is 150. So 150 equals to 150. So we need to basically prove this. Okay. So how can we prove? So assume that we are having two numbers A and B. Now let GCD of A and B be given by D. And let LCM. So if A and B have GCD as D, then can we write F to be A divided by D? See, if we are having a number A and its GCD is D, GCD is D means it is a multiple. So D will obviously divide A and F will be that factor. And we can write F equals to AD. We can write E equals to DF. Okay. Now let us suppose that if we can write it like this, then we can also write G equals to B by D. See, if the GCD of B is D, then definitely D will have some factor. Let us suppose it to be B. D will have some factor which is G, by which D can divide B. See, in this example what happened was, in 10 and 15 its GCD was 5. So what is that factor? That factor is 15 by 5, that is 3. So here this is G, this is B and this is D. So the same we have written over here, and we can rewrite this statement as B equals to GD. Okay, so we got these two statements. Now let us suppose that the LCM, this is for the GCD part. Now let us suppose that the LCM of A and B is C. Okay, now we know that the LCM is C. So LCM has to be divisible by A. See, if it is a multiple of A, see, this is a multiple. C is a multiple of A. So C is divisible by A, C is divisible by A. Okay, and we can rewrite this as C is divisible by A and B both. C is divisible by, what is the value for A? DF. C is divisible by DF and what is the value of B? GD. Okay, so C is divisible by DF as well as GD. Now see, here observe one thing. You can easily see that F and G will do not have any other common factor. Why? Because let us suppose F and G had some common factor as 2. Let us suppose F was 6 and G was 8. Then they have a common factor as 2. It won't be possible, because if they had a common factor as 2, then that common factor will get shifted over here to the D, and D would be having a larger value, because this is the greatest common divisor. So that 2 will become part of the D. So we can easily say that F and G won't have any other common factors. Otherwise D would have been bigger by that factors. So we can write C as D into F into G. Okay, C can be written as D into F into G. It is the smallest possible number. Why? Because we cannot have a common factor among D and G and this. We cannot have a common factor among F and G, and D is the GCD and F is the and C is the LCM. So LCM can be written as D into F into G. It is the smallest number. Now see this statement. Now we have to prove that A into B equals to LCM into GCD. Okay, so A into B, we can write A value to be equals to D into F. Yes. We can write B value equals to G into D. Yes. Now let us take D over here and D into F into G over here. D, and what is the value of D into F into G? It is equals to C. So what is this D? D was equals to our GCD. And what is this C? It was equal to LCM. So we have proved that LCM into GCD equals to the product of the number. So we have basically proved this statement. Okay. Now we will see the statement B. But first of all, let me clear this stuff out. Okay. So what is our option B? So option B is saying, consider the following first order formula. Okay. For all x, there exists a y such that Rxy. Okay. Which means if we have an x, then definitely we will have an y such that x will be related to y. Which means for all x, if we have a x1, we will have a y for it. If we have a x2, we will have a y for it. They may have a common y. If we have a x3, we will have a y for it. We will have a y for it. Okay. Let us try to break it down in the form of a graph. It will be more easier. So what it means, if for all x there exists a y, it means for every node there will be an outgoing edge. For every node there will be an outgoing edge, which means it will be related to something. Okay. Now let us see option B. For all x, for all y, if Rxy exists, then Ryx do not exist. Okay. So what it means in terms of graph, if we have an edge from A to B, then it means that we can't have an edge from B to A. Okay, if there is a directed edge from A to B, then we can't have an edge from B to A. This is the anti-asymmetric property. This is the asymmetric property, which means if we have an edge from over here to here, then this implies that we can't have an edge from here to here. Let us name this as A and B. If we have an edge from A to B, then we can't have an edge from B to A. Okay. Now let us see this option. For all x, for all y, for all z, if Rxy exists and Ryz exists, which means if we have an edge from A to B, or if x is related to y and y is related to z, which means we have an edge from B to C, then we will have an edge from A to C, or we can say Rx is related to z. This is called the transitive property. Okay. Yeah, which means if we have an edge from over here to here and from here to here, then it means we will also have an edge from here to here. Let us rename as A, B and C. If AB has an edge, BC has an edge, then AC will also have an edge. Now let us see option D. Part D. Part D is for all x. X is not related to x, which means in terms of the vertex, we can see we cannot have a self loop. No self loops. Or we can say irreflexive relation. Okay. Now we can easily see that we cannot have a graph with all these properties. Let us try to generate one. Let us take 3 vertices. Okay. See, every vertex must have an outgoing edge, so this must have an edge, this must have an edge, and this must have an edge. We can't have S to the same vertex, so they must go to some other vertex. Let us suppose from A it goes to B. Okay. Now B can't have an S to A because of this second property, so B will definitely have an S to C. Perfect. Now C can't have an S to C because of this irreflexive property. C can't have a S to B because of this asymmetric property. C can't have a S to A because of asymmetric property. So this is not possible. So we can't have a graph like this. Let us try to also prove this with the help of a contradiction. Okay. So we will assume that, let us suppose we have a structure S with V vertices and E edges, such that the cardinality set of V is n, which means we have a graph. In terms of graph, we have a graph S with n vertices. Let us assume, and it follows all these properties. Okay, now we have to prove that this is a contradiction, that it shouldn't be happening. Okay, so if we are having n vertices and n belongs to natural number. Okay, so what we mean by property A, it means everyone should have an outgoing edge. So it means we should have n outgoing edges according to property 1. Okay, let us rename this as property A outgoing edge property, property B asymmetric property, property C transitive property, and property D irreflexive property. Okay, now see, since no symmetric edges are around S, it is having asymmetric property. Okay, and no self loop was allowed due to this property D, which is the irreflexive property. Thus, by pigeonhole principle, we must have at least n cycles. We must have an n length cycle by the pigeonhole principle. Okay. Now see, any transitive relation on n elements with an n cycle is an equivalence relation. This is a property. What is the property? The property is any transitive relation. See, this is a transitive relation. We have proved this. This is a transitive relation. Any transitive relation on n elements with n cycle. N cycle by pigeonhole principle. With n cycle must be an equivalence relation. What is the meaning of equivalence? It should be reflexive, it should be symmetric, and it should be transitive. Okay, but see, but this is not reflexive and not symmetric, it is only transitive. Thus this is a contradiction, like we cannot have a graph with n vertices which follow all these properties. So here we can easily say it cannot have a finite model, which means we cannot have a finite model following all these properties. All these properties cannot be followed by a finite model. No. Okay, it can be followed by an infinite model. Infinite model can follow. If an infinite model can follow, it means it is satisfiable. Not by a finite model, but by an infinite model. Okay, let us see an example. Okay, let us take the less than equal to relation. A relation Rxy is defined as x is less than 1, which means 1 will be related to 3 as 1 is less than 3, 3 will be related to 5 as 3 is less than 5. Okay, so everyone will be less than something, as we will have infinite as a larger number, so there will be definitely someone greater than every number, so property A is followed. If 3 is less than 5, then 5 can't be less than 3, so property second is followed. If 3 is less than 5 and 5 is less than 7, then 3 is less than 7 for sure. Thus transitive property is followed. 3 can't be less than 3 as it is not less than equal to, is strictly less than. So property D is followed. Thus we can have an infinite countable model, and this is the model. So it is satisfiable, we can have an infinite model, but we cannot have a finite model following it.